Hey there, knowledge seeker, and welcome to a fresh deep dive.
Hello.
You know how sometimes you just crave those little nuggets of information that make you go, whoa, that's actually a thing?
Absolutely. Those little facts that just stick with you.
Well, we've been doing some serious digging through the fascinating world of BBC Science Focus magazine,
Mm,
and we've unearthed 10 absolute crackers for you. Get ready to have your science radar recalibrated.
that's right. Forget the surface level stuff. We're plunging headfirst into these 10 surprising science facts.
Yeah.
Our aim isn't just to tell you what they are, but to really get under the skin of why they're so unexpected and, ultimately what they mean for how we see the world.
Like the so what behind it all.
Exactly. Think of this as your fast track to those water cooler moments where you drop some truly mind-bending science.
Okay, let's kick things off then. And this first one,
Mm.
it's really going to challenge your senses, I think. We're talking about comets, those icy travelers zipping through space. Now, what's the first thing that comes to mind when you think of a comet? Probably not its smell, right?
Definitely not.
Mm-hmm.
You think ice, dust, maybe a tail,
Mm.
not aroma.
But apparently, these celestial snowballs have a rather, well, distinct aroma.
Indeed, the Rosetta mission actually got up close and personal with Comet 67 Churyumov-Gerasimenko.
Right, the lander philae.
That's the one. And the data they collected about its composition revealed a rather pungent mix of chemicals. We're talking hydrogen sulfide,
Which is
the main culprit behind the smell of rotten eggs.
rotten eggs in space. You couldn't make it up. But wait, the olfactory adventure doesn't end there, does it? It gets even more complex.
It does. Alongside the hydrogen sulfide, scientists also detected ammonia,
Ammonia, okay, like cleaning products or
or more pungently, urine, that kind of smell.
yikes. Okay.
What else? Then there's sulfur dioxide, that sharp, acrid scent you get from striking a match.
Right. Okay. So rotten eggs, urine, burning matches.
Yeah.
What a cocktail.
And perhaps most surprisingly, a hint of hydrogen cyanide.
Hydrogen cyanide. Isn't that poisonous?
It is, yes. Highly toxic in concentration.
And it smells like almonds, right? That's what they say. Talk about a deceptive scent profile.
Exactly. What's fascinating here is how these seemingly disparate and, yeah, even dangerous chemical compounds can come together to create the overall smell of a comet.
So it's the mix that matters.
It really underscores the complex chemical processes happening in these ancient objects. And yes, while pure hydrogen cyanide is indeed toxic in the trace amounts detected, its contribution is primarily to the overall odor profile.
And to really highlight just how bizarre this was, I remember reading that they even created scented postcards back in 2016, supposedly replicating the comet's smell.
They did, yes. It's
Yeah.
a rather unique public engagement thing for the Rosetta mission.
Did anyone actually get to sniff one? Was it awful?
I believe they were distributed. It certainly made the discovery more tangible, even if the tangibility was, well, olfactory and maybe not entirely pleasant.
Huh. Okay, all right. From cosmic stenches to something a bit closer to home, the ground beneath our feet, literally.
Okay.
Our next surprising fact is that Earth's poles are not exactly reliable tenants, they're constantly on the move.
Oh, yes, magnetic north.
Now, most of us know the magnetic North Pole isn't the same as the geographic North Pole, but the rate at which it's shifting is pretty astonishing.
It is. And it's not just shifting. The Earth's entire magnetic field has a long history of flipping its polarity. North becomes south, south becomes north.
Full reversal.
Yeah. This has happened many times over geological history. The evidence suggests around 171 times in the last 71 million years.
171 times. Okay, so on a geological timescale, it's almost routine then.
Sort of, yeah. But here's the kicker, right? Based on the average timing between reversals,
We're due.
we're generally considered overdue for the next one. It's like the planet is on this slow motion pendulum swing, and we're kind of waiting for it to reach the other side.
Huh. And what about the current movement? You said the rate was astonishing.
That's what's particularly capturing scientists' attention right now, the speed of the North Magnetic Poles movement. Up until about 1990, it was drifting at a relatively steady pace, maybe 15 kilometers per year.
Okay. Still sounds like quite a bit.
But in recent decades, that speed has dramatically increased. It's now clocking in at around 55 kilometers per year.
55, wow. That's like the magnetic North Pole deciding it's had enough of the Arctic and is making a run for Siberia, isn't it?
Pretty much, that's the direction it's heading.
What could be causing this acceleration? And I mean, what are the potential consequences of such a rapid shift, let alone the eventual reversal?
Well, the precise reasons for the speed up are still being investigated. It's likely linked to changes in the flow of molten iron in Earth's outer core, That's what generates the magnetic field in the first place.
Right, the geodynamo.
Exactly. As for consequences, well, a full magnetic reversal could potentially impact navigation systems that rely on magnetic readings. GPS isn't affected, but compasses obviously are. And there are ongoing studies into its effects on satellite technology, maybe even the Earth's protection against solar wind, though that's debated. The rapid pace of the current movement is definitely a significant area of research, even without a full flip.
Okay, fascinating stuff. Right, this next fact takes a bit of a darker, albeit surprising turn.
Oh.
You can actually die laughing.
Yeah, I've heard this one mentioned.
I mean, we all use the phrase dying of laughter, but to think it's a genuine physiological possibility, that's quite sobering, isn't it?
It is. And while it's extremely rare, let's be clear about that.
Very rare.
Very rare.
Yeah.
But there are documented instances where intense, uncontrollable laughter has directly led to death.
How? What actually happens?
The primary physiological mechanisms seem to involve either a fatal cardiac event, like a heart attack.
Triggered by laughing?
Yeah, triggered by the extreme physical exertion and the rapid changes in blood pressure and heart rate that can happen with really uncontrollable laughter. Or asphyxiation.
Suffocation.
Yes, due to prolonged and severe spasms affecting breathing. You can't catch your breath.
So all those times we've been doubled over, gasping for air from laughing so hard, we were maybe teetering on a surprisingly literal edge.
In a very, very remote way, perhaps. It almost makes you wonder if comedy shows should come with a disclaimer. Warning. May cause actual death.
Slightly dark humor there.
It is a darkly humorous thought, but it really highlights the powerful connection between our emotions and our physical state, doesn't it? Even something as seemingly benign and positive as laughter can, in extreme, rare circumstances, have serious physiological consequences.
Okay, wow. From potentially fatal chuckles to something truly unexpected in the history of tools, chainsaws.
Right. Lumberjacks, trees.
Exactly. Except originally they were invented for childbirth.
Yes. My brain just does a little flip every time I hear that. It seems so counterintuitive.
It really does. I
Yeah.
immediately picture burly lumberjacks, not, assisting in deliveries.
It's a surprising twist. They were developed back in Scotland, late 18th century.
So quite a while ago.
Yes, and the early chainsaw was indeed a medical instrument. Its initial purpose was to aid in a surgical procedure called symphysiotomy.
Symphysiotomy, what's that?
It was a highly risky procedure, really a last resort, performed to widen the pelvic opening during difficult childbirths, essentially cutting through the cartilage of the pubic symphysis.
Oh my goodness, with a chainsaw.
A much smaller hand-cranked version, obviously, not the roaring machines we know today, but yes, a chain with cutting teeth. These early versions were also used for removing diseased bone in similar obstetric or surgical situations.
Wow. So instead of felling trees, the first chainsaws were designed to, quite literally, help bring new life into the world in very, very challenging circumstances. That's a profound difference.
A huge difference. It wasn't until the early 20th century that the design was adapted, made more powerful, and found its primary use in the logging industry for cutting timber.
It's a fascinating example of how an invention's purpose can just completely evolve, isn't it? Based on needs and technology.
Absolutely. From surgery to forestry. Quite the journey.
Okay, let's zoom in now, way down to some of the smaller creatures around us. Ants.
Okay. Tiny but mighty.
Turns out these incredibly industrious insects have a completely different way of taking in oxygen than we do. No lungs for these guys.
That's correct. Unlike us mammals, ants don't possess lungs at all. Instead, they have this network of tiny external openings all over their body. They're called spiracles.
Spiracles. So they're essentially breathing through multiple tiny pores spread across their exoskeleton, like little vents.
Precisely. These spiracles lead to an intricate internal network of tubes called tracheae.
Tracheae, okay.
And this tracheal system delivers oxygen directly to the ant's tissues and cells throughout their body. It bypasses the need for a circulatory system to transport oxygen like our blood does.
Huh. How many of these spiracles do they have?
The number can vary slightly depending on the ant species, but typically they have around 9 or 10 pairs along the thorax and abdomen. It's a remarkably efficient system for creatures of their size.
It's amazing, isn't it? All the different solutions evolution has devised for even the most fundamental biological processes, like just breathing.
Absolutely. It really underscores the incredible diversity of life on our planet. There isn't just one right way for life to thrive. Different environments and body plans necessitate different physiological adaptations.
No lungs needed if you're small enough, apparently.
Pretty cool, see.
Seems that way.
Now, for a fact that might make you rethink your childhood image of a certain iconic dinosaur.
Let me guess. T-Rex.
You got it. The mighty Tyrannosaurus rex likely sported feathers.
The fluffy tyrant image.
I always pictured it as the ultimate scaly reptilian predator, like in the movies.
That long-held image is likely in need of a feathery update. Scientists working in China have discovered some exceptionally well-preserved fossils.
Fossils of T-Rex itself.
No, fossils of its ancestors, tyrannosaurs dating back to the early Cretaceous period. And these fossils show clear evidence of feathers, filamentous feathers like down. So we're not just talking about distant relatives, we're seeing actual feathered members of the Tyrannosaur family tree. Close relatives.
Exactly, like Tyrannus. And the logical conclusion drawn from these discoveries is that if these earlier large relatives possessed feathers, it's highly probable that Tyrannosaurus rex itself did too.
But maybe not everywhere. Or maybe only when young.
That's the ongoing discussion. At least during some stage of its life, or perhaps on certain parts of its body, these wouldn't necessarily be the large flight feathers we associate with birds today,
Right.
but more likely those downy filaments, possibly for insulation, especially when young, or perhaps for display.
A giant, possibly fluffy apex predator. It definitely adds a new dimension to the terror, or perhaps the slightly less terrifying image of the T-Rex.
It certainly does. It's funny how new evidence can completely reshape our understanding, our mental picture of the past.
Yeah, it highlights the dynamic nature of science, doesn't it? Always refining, sometimes completely overturning old ideas.
Constantly learning.
Okay, this next one is a bit of a surprise from the world of sports. Apparently, the color of a football team's kit, specifically the color red.
Red kits, okay. Like Liverpool, Man United, Arsenal.
Exactly. That color can actually have a subtle impact on their performance.
Interesting. This delves into the fascinating intersection of psychology and sports performance, right?
Seems so. Research including a comprehensive review of football matches spanning 55 years.
55 years. That's a lot of data.
Yeah, it suggests a correlation between teams wearing red kits and slightly better performance, specifically in home matches, compared to teams in other colors like blue, white, or yellow.
Better how? Are we talking about scoring more goals or a higher win percentage? What kind of advantage could a color possibly provide?
The review indicated a consistent, albeit small, statistical advantage for teams playing in red at home. We're talking win rates.
Okay, small but consistent. So what's the theory? Why red?
Well, the prevailing theory revolves around the psychological impact of the color red. It's been shown in various studies to be associated with dominance, aggression.
Right. Danger signals, dominant signals in nature often involve red.
Exactly. And even potentially increased testosterone levels, both in the wearer and perceived by observers. So this perception could subtly influence both the players wearing red, maybe making them feel a bit more assertive,
Okay.
and the opposing team, perhaps leading to a slight sense of intimidation or making them play more cautiously.
And maybe even referees, subconsciously.
That's been suggested too, yeah.
Yeah.
It might subconsciously influence referees' decisions in those marginal 50-50 calls.
So it's not necessarily about some inherent aerodynamic property of red fabric.
No, definitely not.
It's more about the psychological cues and perceptions it triggers on the field. That's a really interesting insight into the non-physical factors that can play a role in competitive sports. Precisely. It underscores how intertwined the psychological and physical aspects of athletic performance can be, and how seemingly minor details, like shirt color, can have subtle but measurable effects.
Wild. Okay, let's move on to a topic that's important in our pursuit of cleaner energy. Wind turbines.
Renewable energy. Crucial, but with challenges.
Exactly. While they're crucial for renewable power, they unfortunately do have an impact on bird populations.
That's a critical consideration, yes. It's one of the environmental trade-offs. Current estimates suggest that wind turbines in the UK,
just the UK.
this study focused there,
Uh-huh.
they contribute to the deaths of somewhere between 10,000 and 100,000 birds annually. It's a wide range because it's hard to measure accurately.
Even 10,000 is a lot. That's a significant toll on avian wildlife. It raises important questions about how we can minimize these negative consequences as we build more turbines.
Indeed. And what's particularly encouraging here is the discovery of a relatively simple, yet remarkably effective potential solution.
Okay, what is it?
Painting just one of the 3 turbine blades black.
Just one blade. Black, that sounds almost too simple.
It does, doesn't it? But research, particularly a study in Norway, demonstrated that this seemingly small change can reduce bird deaths, particularly raptor deaths, by an impressive 70%.
70% reduction, just from painting one blade black. How? What's the logic behind why this works so well?
The leading hypothesis is that the single black blade creates a crucial visual cue for birds in flight. It breaks up the solid blur.
Ah, so the uniform white or gray blades rotating can create this kind of motion smear that's hard for birds to judge.
Exactly. It can be difficult for birds to perceive clearly, especially against certain backgrounds or in certain light conditions. The contrasting black blade likely breaks up this visual ambiguity, making the rotating turbine much more conspicuous.
Making it easier to see and avoid.
It allows birds more time to react and avoid collision. It's a testament to how understanding animal perception can lead to practical and hopefully effective conservation measures.
That's genuinely fascinating and actually a real beacon of hope for finding better ways to balance renewable energy and wildlife protection.
It really highlights the power of targeted research and innovative thinking in addressing these environmental challenges. Simple solutions can sometimes be incredibly powerful.
Absolutely. Okay, our penultimate surprising fact. Number 9. This takes us down to the miniature world of mollusks. Snails
Slow movers, slimy trails.
have thousands of teeth. That's the last thing that comes to mind when I picture a garden snail munching on a leaf.
It is quite unexpected, isn't it? Depending on the specific species, a snail can possess anywhere from 1,000 to an astounding 12,000 teeth.
12,000? But how? Where? I mean, you don't see them grinning at you.
No, definitely not. It's important to adjust the mental image here. We're not talking about a conventional toothy grin like ours. Their teeth are quite different.
Okay, so if they don't have rows of pearly whites, what exactly are these thousands of teeth? Are they microscopic or something?
Precisely. They're tiny, hard structures called denticles, and they're located on the snail's radula.
Radula.
Yeah, it's a specialized ribbon-like or file-like organ in their mouth, essentially a kind of tooth tongue.
A tooth tongue. Okay.
And these miniature teeth, the denticles, are arranged in rows on this radula. They're used for scraping and grinding food, like algae off rocks or tearing plant matter.
So it works like a tiny little rasp or file.
Exactly. Think of it as a very fine, abrasive surface that helps them break down their meals. So while the sheer number is remarkable, their size, structure, and function are quite different from our own teeth.
A toe covered in thousands of microscopic teeth. That's a truly unique adaptation. Slightly unsettling, maybe.
The natural world never ceases to amaze with its inventive solutions, does it? It's another wonderful example of the incredible diversity of feeding mechanisms that have evolved.
Totally. Okay, final fact. Number 10. This one delves into the realm of sound, or perhaps more accurately, the absence of it.
The sound of silence.
Kind of. Apparently, sound can actually be measured in negative decibels. That really bends my understanding of the decibel scale. I always thought 0 was the absolute quietest possible, the bottom.
That's a common and understandable misconception. The decibel scale is actually a logarithmic scale.
Right, like the Richter scale for earthquakes.
Sort of, yes. It measures the intensity of a sound relative to a reference point. And that reference point, 0 dB, is set at the approximate threshold of human hearing, the quietest sound an average young, healthy ear can detect.
Okay, the threshold.
But because it's a ratio based on that reference, it is indeed possible to have sound levels below that threshold, environments quieter than the theoretical limit of our hearing, hence negative decibels.
So negative decibels just means quieter than the average human can normally perceive.
Exactly. Much, much quieter.
And where on our planet would you encounter such a profound quiet that it actually dips into negative decibels?
Well, the Guinness World Record holder for the quietest place on Earth is Microsoft's anechoic chamber. It's in Redmond, Washington, USA.
An anechoic chamber, meaning no echo.
Precisely. And it has been measured at a staggering negative 20.6 decibels.
Minus 20.6.
Yeah.
It's hard to even imagine. How is such an extreme level of silence even achievable? What's the room like?
Anechoic chambers are meticulously engineered environments. They're designed to absorb virtually all sound reflections echoes. They are constructed using specialized sound-absorbing materials, often shaped into deep wedges covering the walls, floor, and ceiling.
Like foam wedges.
Often, yes, or fiberglass.
Yeah.
And the entire chamber structure is typically isolated from its surroundings. It might be built as a room within a room, sometimes even mounted on giant springs.
On springs?
Yeah, to prevent any vibrations from the building or the ground outside from getting in. The goal is to create an environment with the absolute minimum of background noise.
Wow. What would it feel like to be in a place that quiet? Can people stand it?
Experiencing such extreme quiet can be quite disorienting for humans. People aren't used to it. Many report being able to hear their own internal body sounds.
Like what?
Your own heartbeat very clearly. The sound of your blood flowing, maybe a faint whooshing. Some people even become acutely aware of the faint ringing in their ears, tinnitus, that's normally masked by ambient noise.
That sounds both incredibly fascinating and slightly unnerving. A space so devoid of external sound that your own internal biology becomes the dominant soundtrack.
It really forces you to reconsider our everyday experience of sound and silence, doesn't it?
Yeah. It highlights the complex interplay between sound waves, their physical measurement, and our subjective perception of them. What quiet really means.
It certainly does.
Well, there you have it. 10 truly surprising science facts spanning, the cosmos with smelly comets, down to the microscopic world of snail teeth, and even touching on the unexpected influences of color in sports and the evolution of everyday tools like chainsaws.
Quite a collection. Who knew delving into science could uncover such a bizarre and fascinating range of insights?
Exactly. And hopefully you, our listener, have experienced a few of those aha moments we were aiming for.
Yeah, those moments of, wait, really? From the peculiar aroma of comets formed billions of miles away to the silent depths of a specially designed room right here on Earth. These facts remind us that the universe, at every single scale, holds an endless supply of surprises waiting to be revealed.
Absolutely. It really makes you wonder about all the other unexpected truths that are out there, just waiting for a curious mind to uncover them.
Keeps science interesting.
It does. So maybe think about this. What seemingly ordinary aspect of the world around you, something you see every day, might hold an extraordinary secret? We hope this deep dive has ignited your own passion for exploration and discovery. Keep questioning.